Welcome to video lesson 9.6, factoring difference of squares. Go ahead and put today's date in the top right hand corner. And our target for today is that I can factor polynomials by difference of squares. Now, difference of squares factoring is for two terms, like how GCF is for any number, grouping is for 4, DoS is for two terms. A lot of times when I'm talking about difference of squares, because it's a long name, I'll just call it DoS. That way, it's a little bit shorter to say, and also whenever we write out what type of factoring we need to do, DoS is easier to write than difference of squares. So the word difference in math we know means to subtract, and we know what squares are. So that comes into play with our two terms. Our two terms must be subtracted or their signs must be different. So that's the difference part. And then squares. Squares means variables must be to an even power or squared. And our coefficients, let me scoot that down a little bit. Coefficients and constants must be perfect squares. Now, we're going to make a perfect square list for those of us who aren't sure what perfect squares mean. That way we can see them. So, our perfect squares. Basically, it's just that number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. This is a good list to make out, that way you can know that all of these on the right side of the equal sign are your perfect squares. Then the left side tells you what numbers makes them. So it's like if I were to ask you, what is the square root of 49, you would know it's just 7. And also, if you think about something being squared, we've talked about this before. If I have x squared, it breaks apart into x and x, so that means I have two x's. Same way, if I have 7 squared, that means I have 7 times 7, and 7 times 7 is 49. So that means we have two of the same number being multiplied. Alright, one thing just to remember is if you don't remember your perfect square list, the opposite of a square is a square root. So if you want to know the perfect squares of 64, then just take the square root of 64 and you'll get 8. So if you take the square root of like 50 and it gives you a decimal, you know it's not a perfect square. The perfect squares give you a nice whole number. Alright, our steps. Step 1 is always to check all terms for GCF. That's always the very first thing we do. Then step 2, we're going to check and make sure our polynomial only has two terms, because DoS is only for two terms. Make sure it's subtraction, and make sure our terms are all perfect squares. Find square roots of all the terms. And lastly, our answer is written, and we have two parentheses again, two binomials like we did with grouping. So our first parenthesis has the first square root, and this plus sign, our second square root. And then our second parenthesis has our first square root minus our second. So basically, the parentheses are going to have the same things in them, except for one's going to be a plus and the other parenthesis is going to be a minus. So let's see an example of a DoS factoring. So example 1, we have x minus 16. So x squared minus 16. So very first thing we do is check it for GCF. His coefficient's technically 1, so I don't have to show a GCF of 1. He has an x, he doesn't, so no GCF. So then we know it's a DoS. Because I have two terms, x is being squared, and 16 is on our perfect square list, and they're being subtracted. So, Two terms, subtraction, perfect squares, we're good. So then we take the square root of both of these terms. So the square root of x squared and the square root of 16. And what I like to do at this point is just go ahead and make my two parentheses. And say square root of x squared cancels and just leaves me with x. So goes in first and the second parenthesis. And then our signs are different, so a plus and a minus. And then square root of 16 is 4 and 4. Now you can check these the same way we check our other problems. It's the opposite of a FOIL problem. So if you look, this is a special product because I have one that's a plus 4 and the other one is a minus 4. So special products means we just have to multiply our first term. So x times x gives us x squared. And our last, 4 times negative 4 is negative 16. And we check x squared minus 16 is our original problem. So let's see another one. We have 64 y squared minus 81. So the very first thing we do is check it for GCF. So 64 cannot go into 81 evenly. You try the factors of 64, they still don't work. He has a y, he doesn't. So there's no GCF, so then we move on to DoS because we have two terms and we check it. 64 perfect square. Yep, it's on our list. Y is being squared, and 81 is also on our perfect square list. And lastly, we are subtraction, so we're good. So we're going to now move on. We're going to take the square root of everything here. So square root of our first term, square root of our second. We're going to make our two parentheses. There we go. So square root of 64 is 8, so I put 8 first in each. Square root of y squared is just y, so 8y and 8y. Our signs are different, so it's going to be a plus and a minus. Square root of 81 is 9, so 9 and 9. That's our answer. There we go. So let's move on to a couple of other examples. Our next one has 9x squared minus 25y to the fourth. So once again, the first thing we check for is GCF. 9 cannot go into 25 evenly. Factors of 9 cannot go into 25. He has an x, he has an y, so there's no GCF. So then we say 9 is a perfect square, x is being squared. We have subtraction, 25 is a perfect square, and y is to an even power, so that means it's a DoS. And now we take the square root of everything here. I make my two parentheses. Now, square root of 9 is 3. So 3 and 3. Square root of x squared is x. Alright, my signs are different, so a plus and a minus. Square root of 25 is 5 and 5. Now, y to the fourth, it has to be to an even power because, like how we said, x squared breaks apart into x and x. Well, our y to the fourth is going to do the same thing. Y to the fourth is going to break apart into y squared and y squared. So it has to be an even power so I can separate it evenly. If it had been to the 6th power, it would have been a 3 and a 3. So the square root of y to the fourth is y squared and y squared, because it can break apart evenly into 2 and 2. There we go. And also, if you think about when we're multiplying, you're going to add your power. So y squared times y squared is going to be y to the fourth because you add on 2 plus 2. Alright, example 4. We have 8v to the third minus 18v. Step 1, we check for GCF. And both these numbers are even, so we know it has a GCF of at least 2 because they're both even numbers. So we see, can 8 go into 18 evenly? No, so then we find our factors of 8. We try next 2 and 4. 4 is bigger, so can 4 go into 18 evenly? No, it can't, so then we use our 2. and 2 can go into 18 evenly, so GCF of 2, and they both have V's. I want the V with the lowest power, so that's just V. So I divide everybody here by 2V. And because it's GCF, GCF goes on the outside, I'm going to make my parentheses. So 2V, then 8 divided by 2 is 4. V to the third divided by V gives me V squared, minus 18 divided by 2 is 9, and V divided by V cancels. And this is just using our rules for monomials, knowing that if that's 3 and that's a 1, we subtract. So 3 minus 1 gives us V squared, and V divided by V cancels. So we have to use those monomial rules still when we do our GCF. So now we check inside this parenthesis. And we look, it has 2 terms. 4V squared, so both those are perfect squared. It's subtraction, and 9 is a perfect square. So that makes it a DoS now inside there. So that means we're going to have to break apart our 4V squared minus 9. So I'm going to drop down my 2V, cannot lose my GCF. We know this breaks apart into 2 parentheses. Now we find the square root of 4V squared. So square root of 4 is 2. Square root of V squared is just V, so 2V, 2V. Signs are different, a plus and a minus. And then our square root of 9 is 3 and 3. That's our answer. And our can statement is I can factor the sum or difference of cubes. Now, sum or difference means we're allowed to add or subtract. So sum or difference of cubes is for 2 terms, and both terms are perfect cubes. That means we're going to have the power of 3. Now, saying sum or difference of cubes takes a long time to say, so I just say sum of cubes, which is SoC, and difference of cubes is DoC, so I call it SoC and DoC. So SoC and DoC is for perfect cubes, and I made us our perfect cube list like how we did our perfect squares. So here's our perfect cube list. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. And just like how the opposite of a square is a square root, the opposite of a cube is a cube root. And cube roots look like this right here. It has a 3, and then your radical bar. Try that radical bar again. There we go. So that's what a cube root looks like. So the opposite of a cube is a cube root. Now our steps. Oh, there we go. Step 1 is always to check for GCF. Step 2 is to check 2 terms and make sure that they are perfect cubes. Step 3 is to make your first parentheses. So SoC and DoC is one of those I like to make my answer as I go. So make the first parenthesis and take the cube root of both terms. Step 4, we're going to go ahead and make our second parenthesis and follow the next steps, and we ignore the signs. We're just going to pretend that we don't see them for our second parenthesis. So we're going to square our first term and put it square the first term in the first parenthesis, and that's our first and our second parenthesis. Then we're going to change our sign. So if it's a plus, we're going to make it a minus. If it's a minus, we're going to make it a plus. Multiply the terms of the first parenthesis together. We're going to make the next sign always a plus sign. And then we're going to square the last. And that's the last term in first parenthesis. Alright, then step 5, we just write out our answer. And our answer for this one looks a little bit different because we have the cube root of our first term and then plus or minus the cube root of our second term. And then for our step 4, we square the first term, we change our sign, we multiply our first and last terms together. It's always a plus sign, and we square our last. And for SoC and DoC, following through these steps is about the easiest thing we can do. So we'll keep our steps handy as we do our first example. So let's see our first example. We'll do this number so we can still see our steps. So example 1, we have 8y to the third plus 27. Try to make this a little bit bigger for us. So 8y cubed plus 27. So step 1 says check for GCF, so we see 8. We say, can 8 go into 27 evenly? No. And our factors of 8 would be 4. So 4 can't go into 27, and 2. 2 can't go into 27. They don't have any variables in common, so no GCF. So step 2, make sure they're perfect cubes. So I have an 8. 8's on our perfect cube list. We have a 27. 27's on our perfect cube list, so we're good. So now, step 3 says make first parenthesis and take cube root of both terms. I'm going to skip a line, give yourself some room to write the next one. So skip a space and then make your first parenthesis. Take the cube root of 8y cubed. So cube root of 8, if you look over here, is 2. And then the cube root of y cubed is just y because cubes cancel. Now I'm going to drop down my plus sign and say the cube root of 27. So over here on your cube root list, it's 3. So 2y plus 3. We have our first parenthesis. Now on that same line where we skipped some space, I'm going to make my second parenthesis. We have to make it big enough for 3 terms. It's going to be a trinomial. So now we're going to follow these steps right here at step 4. So we're going to square the first term in first parenthesis. So right here, I have my first term is a 2y, so I'm going to say 2y, and the whole thing squared. So this takes us back to our monomial notes. I have to say 2 squared is 4, and y squared is going to be y squared. Alright, then our next one is we change the sign. So if it's a plus sign here, in my next parenthesis, I'm going to change it to a minus. Now for our second term, we're going to multiply the terms of the first parenthesis together. So I get 2y times 3. That's going to give me 6y. And it says always a plus, so then it's a plus sign. Then we're going to square the last in the first parenthesis. So my last term, my first parenthesis is 3. So we're going to square 3. And 3 squared is 9. And that's our answer for our SoC and DoC. Just go through there and make sure you multiply, make sure you just follow those steps. And when you multiply right here, just make sure you multiply the terms without their sign. So it's just 2y times 3y. And even though it has a minus sign in front of it, we know we had to change our sign, because that's what our steps told us to do. So just go through there for SoC and DoC. Just do those steps. Now if you want to check it, you just distribute. You do 2y times everybody in the second parenthesis, then you do 3 times everybody in the second parenthesis. And it'll come out being our problem, 8y cubed plus 27. So let's see another example. We have 64w cubed minus 343y cubed. So we're going to follow through those steps. Step 1, check. Make sure we don't have a GCF. So 64 cannot go into 343 evenly. And go ahead and tell us the factors of 64 won't go into 343 evenly. So then we're going to go on. Say 64 is on your perfect cube list. It breaks apart into 4. 343 is on your perfect cube list. It's 7. And then W's being cubed, Y's being cubed. So we're a SoC and DoC. Everybody's a cube. So I'm going to skip a line and make my first parenthesis. We take the cube root of our first term, so 64w cubed. So the cube root of 64, we already said it was 4. Cube and cube cancels, leaving it with just 4w. And we drop down our minus symbol. And then we say the cube root of 343y cubed. So, cube root of 343 is 7. And cube cancels, and we just get 7y. So now for our second parenthesis, we're going to follow through those steps. So, step 1 is to square the first. So my first term over here is 4w. So 4w squared. So 4 squared is 16. W squared is w squared. Change the sign, so if it's a minus over here in the first parenthesis, it's now going to be a plus. Then for our next one, we multiply together, so 4w times 7y. Remember, we ignore the signs. We say 4w times 7y. So 4 times 7 is 28, and we put our variables in alphabetical order, so w, y. Then it's always a plus sign. Then we square the last, so 7y squared. So 7 squared is 49, and y squared is y squared. And that's our answer. So our step 1 is to always check for GCF, and we try 3. 3 can go into 24 evenly, and if you look, they both have x's. We need x to the first because he's smallest power. So we divide everybody by our GCF of 3x, and our 3x goes on the outside. And we divide. 3 divided by 3 is 1. We don't have to show it. And then our exponents we subtract, so 4 minus 1 gives us x to the third. Minus 24 divided by 3 is 8. X divided by x cancels. So now we look in here. X cubed minus 8 has 2 terms. X is a cube, 8 is a perfect cube. So inside here becomes our SoC and DoC. And actually it's a DoC because it's a minus, it's a difference. So I'm going to skip a line and drop down my GCF, 3x, make my first parenthesis. So we take the cube root of everybody in the parenthesis. So the cube root of x cubed cancels and just leaves us with x. And we drop down our minus. Cube root of 8 is 2. Now we make our second parenthesis and follow our steps. So square the first. So x squared is just going to be x squared. Change our sign, so if it's a minus, it's going to be a plus. Multiply together, so x times 2 gives us 2x. It's always a plus sign. Then we square the last, so 2 squared is 4. And that's our answer. And guys, real quick, just don't forget to drop down your GCF in front. Make sure you got 3x there in front to show that was our GCF. And we're good. That finishes up for SoC and DoC.